Thank you very much for joining us this evening, morning, afternoon, wherever you are, for this, what is in the third event in the series with Algorand. Today is our first kind of hands-on technical event for all of you that kind of want to get kind of started with Algorand, get started even with blockchain in general. And I'm delighted to be joined by Russ and Ryan, who are as good as it gets in teaching you about blockchain in general and Algorand. So we're so pleased to have both of you with us today. Just a general rule for everyone, this event should last about an hour or so, maybe give or take, maybe a little bit longer depending on how questions go. This will be recorded and will go up on the YouTube and the Medium roughly 24 hours after the event, hopefully within that time, so that you can consume the content in your own pace. While Russ and Ryan are speaking, I will paste links to the two previous events. We had two events so far. We had one with Addy from the Algorand Foundation, who gave a good overview of Algorand in general and where it sits in the whole kind of blockchain kind of sphere. And we had an event with Hai Chao, also from the Foundation, who talked us through what a consensus algorithm is and how it works, and in particular what Algorand are doing. But this event is on how to set up your Algorand development environment, kind of very hands-on, very practical. I hope you code along with us. But if you don't, that's fine. You can catch me any time. So Russ and Ryan, over to you. Thank you so much for coming back. And yeah, looking forward to this one.
All right, my pleasure. Let me go ahead and share my screen, and let's just verify we do see the screen okay. Does that look good?
Yeah.
Yep, we got you, Russ.
Well, awesome. Well, welcome everybody. Very happy to be here and get you all going in the Algorand development environment here today. We are joined also by Ryan Fox. Say hi, Ryan, everybody, from Algorand.
Hey, hello.
He's going to be helping out with the questions, so feel free to post them in the chat window. Also, maybe just a hello from everybody. Make sure it's working, where you're from, that sort of thing, and we'll get you used to using that chat window. So I'm a developer advocate for Algorand, and we have a great session on tap for you here today. I'm going to start out with a poll question, a couple poll questions, because I do want to kind of get the lay of the land here and find out what your experience level is. And what I'm going to do is bring up the website that you see there, and let's go ahead and I'll just keep this QR code down here for a little bit. You can do this right on your phone if you want, or whatever. If you want to scan the QR code, that's fine. Or if you want to just join in at slido.com, the number would be 90225. I'm going to get the first poll going. That information will still be on the left, so you can still catch up there. But basically, first of all, I want to know how experienced with Algorand blockchain are you? Now, you can actually choose up to 2 of these. So if I understand some of you have some experience with Ethereum, for example, or some other ones, so answer accordingly. So we got the first 2 choices are brand new to blockchain, period, and brand new to Algorand blockchain. And the next 2 is less than 6 months with Algorand, less than 6 months with any blockchain, and then the last 2 are more than 6 months. All right. I got the results starting to come in now. This is great. Do appreciate that. Okay, there we go. All right, so most of you are brand new to Algorand blockchain, and then more than 6 months with any blockchain, so that's good. So you also have some real world experience there too, and looks like the rest will fall in line. But those are the 2 categories. So we got a lot of novice, and we got some experienced folks with other blockchains. So that's good to know. Thank you. Next question. So very simple. This is the simplest question you'll get today. Are you a developer? Yes, no, sometimes. I know sometimes these hackathon events, they do include marketing type folks. I remember some of my friends at Microsoft when I used to work there entered some hackathons, and they always had a marketing guy because he went around to all the booths to find out what the deals were and who was offering what prizes where. And then he came back and reported out how easy it would be to incorporate that feature to win more prizes, all that kind of stuff. So marketing is very important as well. is the long story there. Okay, now we got a good, most of our folks here today are developers, 56% sometimes, and just probably one or two no. All right, good. And then the next one, what language do you like to use in code when you do Encode? We've got several here to choose from. Python, JavaScript, Java, Go, C#, Java, others. So let's see what our mix is here today. I'll be showing a lot of code today, and we'll have an assortment of languages. This kind of gives me an idea where to spend the time a little bit. So we got good number of entries coming in here. Python, always very big. Other 33%, and Java, JavaScript, Go. Okay. All right, folks, that's a good poll. I'm going to go ahead and end it here and get back over to the deck. All right, let's go ahead and get started then. So what do I need to know to get set up, right, for Algorand blockchain development? You know, first and foremost, do I understand the Algorand blockchain? And then what are some good use cases? I understand many of you are still deciding on projects, or if you have an idea, maybe, you know, you want to put a feature in or something like that. And we'll give you some good examples there. Also layer one, what's in it, and what does an example blockchain solution look like? And I understand many of you do know some of the layer one features that were discussed in the first couple of sessions. So that part will be quick just to make sure we got everybody at the same level. And then, you know, solutions are very important. You know, how do you put all the pieces together? What does a kind of a diagram of typical blockchains, Algorand blockchain solution look like? Code, right? Show me the code. And we got plenty of code for you here today as well. So the agenda then, we're going to just start out with some use cases, getting some basics as well as layer one features, and then lots of good tools the majority of the time we'll be spending. So starting out with use cases, the first one here is Props Network. This is turns app into loyal financial stakeholders. And basically, it's a widget that they have that has loyalty programs. Widget could be for Android, iOS apps, or for web applications. They make it very easy to integrate loyalty programs, and no matter what app that you're building or website solution. SEC approved. And they got tokens, right? Ecosystem for token holders. Tokens, of course, are created with Algorand standard assets. And we'll talk more about that in a little bit. Got a good video that goes along with that. So that's a very good application that's written up on our use cases site. This is brand new. This is not even a week ago. This is CI. That is the Italian version of what CI stands for on top. And English version is Italian Society of Authors and Publishers. And so what they did was they created digital copyright assets using NFTs or non-fungible tokens. And those are tokens that are not identical. They're kind of unique. And over 4 million of these, right? With over 95,000 creators they put on the Algorand blockchain about a week ago. This is just an incredible effort, and NFTs are very, very hot. I wouldn't be surprised if you'd be creating some applications using NFTs. What this facilitated was copyrights for the very first time represented as digital assets. It's decentralized and transparent, like you know, our blockchain is as a result. It's global, which is very important, right? Because a lot of times copyrights were by jurisdiction, right? You'd have like a US copyright or, you know, a copyright from a certain country. Well, there's no boundaries, right? It's a borderless economy, as our saying goes at Algorand. But not only is it a borderless economy, it's borderless NFTs. And so these are global, right? And open infrastructure and available. It gives them end-to-end protection no matter where they are on the planet. So this is really the future of the industry. Anytime there's something that's got to be done with copywriting and that sort of technology, this is how to do it. This is a great model that they put together and a really great use for blockchain. And actually there was, folks, we have hit the mainstream. I just want you to know, I never thought I'd see anything on blockchain on Saturday Night Live, but it happened last week. You know, Saturday Night Live, they had a skit on non-fungible tokens, NFTs, and that's what they were talking about through the whole. It was like a rap video. It was really very entertaining. So if you get to see a rerun on that one, check that out. Very, very entertaining. But I was dying laughing. Very, very cool. All right, and the last in-depth kind of use case here is a Circle and Coinbase. It's a central consortium. And this revolves around payments and treasury infrastructure for the internet. You can accept payments anywhere, send out payments globally. You got the ability to leverage traditional payments with this, as well as through the blockchain infrastructure. And this is done globally, scalable, efficient, all that good stuff. And then we got USDC, right? Is the fastest growing stable coin that they have. And it's 2.3 billion and more in circulation now. So this is if those are unfamiliar with stable coins, basically it's tied to the US economy or tied to an economy of some sort, this kind of a coin. And, you know, one of the problems has been in the past that cryptocurrency does fluctuate quite a bit, and it makes it really difficult for doing transactions. But by having a stable coin tied to the economy, now it fluctuates with the economy, and it's just like, you know, trading real money, right? So it is, a lot more stable in terms of the value that these coins have and doing transactions. All right, a lot of other use cases out there, not just those type of applications that we were just discussing, but just to kind of broaden your horizons, give you a few more ideas for, the thought process on your picking your solutions, developing your solutions you're going to be building. Is a tamper-proof charity organization, right? The China ministry is using blockchain to improve transparency of social services. There was a time when there was a catastrophe and they raised monies, which is the good part of it, right? For, Red Cross. And I think it was about 10 dozen or a dozen years ago, there was a lack of accounting on it. They didn't know exactly where all the monies came from or where it went to. And that's one of the beauties of blockchain. It's built right in. Audit trails are built right into the solution. So that is something they're doing now with all of the donations that are happening in charity cases. That audit trail is right there. To voting, another big area, right? This is tamper-proof. The idea here is that voting and really blockchain can easily detect tampering with the blockchain. It's basically a read-only ledger. And with write once when you're grouping transactions that are added to the blockchain. So that's another good example there. Healthcare, global access, medical records. The on-site coverage team needs to have access to those medical records. The patient may not be in a condition to be able to provide those medical records. Every time you go to a new doctor now, it's like a half-hour experience filling out all the paperwork and all your meds and everything else. So anyway, we got some hope there down the road. Automotive, supply chain visibility, vehicle integrity. What they're doing now is they're actually putting sensors into, into the engine, and they're writing to the blockchain from those sensors. So, very cool stuff there. And I think you can get an idea now, how they're actually using this now, right? Blockchain's not the future; it's the present, and these are real world implementations that are going on in different parts of this globe. But the biggest area by far on blockchain is DeFi. It's exploding. In 2020, over $1 trillion in cumulative blockchain network value, as well as $3 trillion forecast in the blockchain industry for this coming year. That was taken from the Masari IO report. You can see the link down to it. It's a good read for the industry as a whole. So very, very big on DeFi. And DeFi examples with Algorand, and we have a lot of these written up in our use cases. You got IDEX, Monero, Polkadot. You got stable coins like we talked about, USDC, but also Tether. We're going to go next into some of the blockchain basics. And real quick, I came up with this diagram because I was always explaining it this way. And I said, you know what, let me just put this in a diagram and kind of give you a little picture of the different record types on an immutable distributed ledger that what Algorand has. Well, first of all, you got blocks, which is a time period, like 5 seconds go by to build a block. And which I'm sure you learned with Hai Chao in his session on the consensus, right? Then what goes in the blocks are transactions. So there's each block is a one-to-many relationship with transactions. Then transactions are between who? Between accounts. From one account going from sender to receiver, or it could be a logic sig account, which is also related. So accounts have a couple different flavors, right? You got assets, which are your, Algorand standard assets, and applications, which would be your smart contracts, and those all revolve around that. And I'll actually show you a response back when looking at accounts, so you can see all that stuff. This is, the idea, right? If anything you took away from last week's session, and those that missed it, basically is this. In other blockchains, you may have heard of forks or proof of work. No, neither of those are in the Algorand blockchain. So very, very simple. It's just a mathematical equation with a verifiable random function that none other than our founder and Turing Award winner, Suvio Macaulay, came up with. The idea is, back in the Byzantine Empire, you had all of these generals trying to communicate with each other, right? And the scalability of that is it gets to be very expensive, right? It's really a quadratic type equation. So if you get 20 generals, the cost might be 20 squared. But then if you get into like 1 million, the cost is 1 million squared. And this is just not going to fly, especially when we wanted to have a very performant blockchain. So what he figured out is you really don't need everyone to participate. What you simply need is a representative sample. So with that said, the final slide in this section is on the Algorand Pure Proof of Stake protocol. You had a big session on this last week, I believe, but these are the highlights. And the biggest point is the scalability. It's fast. 1,000 transactions per second, under 5-second block times. That really lends itself to things like point of sale transactions, technical flexibility, lots of SDKs, transaction certainty, energy efficient. You can run a node on a Raspberry Pi, very cost efficient. Transactions are less than a penny, and really you get your true security that way too. Great video in the resource. I will have a link to this deck at the end as well. This is a great one for the Pure Proof of Stake protocol. Again, for anybody that may have missed the recording last week or hasn't watched it yet, this is a good supplement. Even if you did, this is a very short video to give you a good example of that. Then we get into layer 1 features, layer 1 versus layer 2. These are features that are built into the blockchain itself versus layer 2, which are solutions built on top of it. The bottom line here is scale is needed for a global blockchain. And other blockchains have tried to run VMs on the blockchain, and that just doesn't work. Those are very resource intensive and very, very slow. And so what we have now are functions right available on the blockchain itself. And this happens really, really quick. And this is a beautiful thing. So you get Algorand standard assets, atomic transactions, and Algorand smart contracts, as well as the ability to do rekeying. So let's just take a quick recap on these. You can see how they kind of fit into that original chart that we had with atomic transactions would wrap not only around transactions, but really different types of transactions, right? Between accounts, assets, applications. You can combine a lot of those together. Rekeying, that really works with the accounts. So you have a public and private key, and you can rekey the private one who's signing. And that gives you some nice flexibility when you're doing growth. And then you also have assets being facilitated through Algorand standard assets and applications with the smart contracts. So getting down to ASAs is a visual way to create these through Algo.io, where you see the screenshot from on the right. These create your native tokens. Administrator functions are provided. These have asset spam protection as well, so you don't have these assets that you could just blindly be distributed. People have to opt into them. Again, all of these 4 things I'm going to be talking about all reside in layer 1. And then if you take a look at examples, we get into our fungible tokens. which are all similar. If you're brand new to fungible or non-fungible, basically stable coins, loyalty coins, these are cryptocurrencies. These are all identical. Each one of these is identical to other ones that are in that category. For example, cryptocurrencies has an algo that is the same value no matter which algo you have. There's nothing unique about it. So you can have multiple of those as well. Then you get restricted fungible tokens for things that can have a clawback maybe capability with securities and government issued fiat. Now we get into the new rave, right? NFTs, in-game items, unique items, anything collectibles are very, very, good way to do NFTs. So these are unique, real estate even, you've got like a 2-bedroom home in one neighborhood versus another neighborhood. There's both 2-bedroom homes, but they're worth different values because there's other metadata, right? That's associated with those, like the neighborhood, or whatever. So you get the idea, I think, on NFTs. Okay, and then there are some links. The one at the top on the NFT resources. This is on our website. Jason, our leader on the DevRel team, put this out last week. So some new information there. You probably would want to go through that article as well. And then, so let's take a look at Algo.io. What we're going to do is we're going to go ahead and create an asset first. And what you would do is copy this. This is your private key. You'd want to copy that off. That would be associated with your account. I'm going to go ahead and get started here. Just create a brand new asset. Let's go pizza Russ. Let's go with 10,000 of those. I'm going to use 1 decimal point. You can put a URL in there, and we'll just leave all the defaults for the rest. But you notice these functions. You got a reserve address, right, in charge of the reserve, the supply. You got a clawback address that's in charge of refunds, right, or getting assets back. And then you have the manager address, which provides functionality and everything. And then you have the freeze address, the ability to freeze assets. So these are all nicely managed out, really well thought out. Let's go ahead and create it. And now what we're going to see is this asset for Pizza Russ gets created. I'm going to go ahead and come down over to the bottom, and we're going to actually see that creation right over here. There it is, Pizza Russ. And you can see the different addresses. Right now, they're all set to the same address. Also, you have the ability to send assets, then modify, freeze, unfreeze, revoke. And because this is a layer 1 feature, this has the same protocol, right, as algos or the native currency. So it prevents things like double spending, and it prevents things like insufficient funds. All that stuff is built right into the consensus. So you get the same benefits here with assets. You don't have to worry about any of that stuff. It's already baked in, and you have the ability to revoke and freeze. Now, what we can do too is take a look at the Explorer. So here's a link to open up the asset in Algo Explorer. So this is one of the two, there's actually a few different Explorers now. And you can see 1 minute ago, that's where it was created. That was the transaction ID. Here is the from address that I have. This is the reserve address. That's a circulating supply. None have been distributed yet. You've got a total supply of 10,000. There's the unit name, which is a very condensed name. Most importantly, there's the asset ID. That's what you need to look at when you are like consuming an asset or getting an asset in one of your wallets, because you can have the same unit name, you can have the same ID, but you can't have, you can have the same unit name or the same long name of the asset, but the ID is unique. So that's a very, very important thing. So if we take a look at, for example, we'll click on this transaction ID and copy here, and we can take a look at one of the other Explorers here. So we got the Goal Seeker by Pure Stake. So here we can switch, again, testnet, mainnet. You got the ability to just put in transactions, blocks, addresses, asset names. So again, these all get reported back. and any additional info that might be associated. Here's the round it was created in, the Genesis ID, and the hash. So anyway, that's a quick tour of that. And then Algo Signer is another great tool, and there's an API that you can use to incorporate with your web app. So it's a Chrome-based plugin, and here you've got the plugin in the corner there. And then you can see once that's done, I'm going to go to mainnet, testnet, and there I have my pizza demo, right? And I could go ahead and send in an asset. So I'm going to send an asset right here and put the to address. I'll send one of these and my note, and then just go ahead and send it. And do that one more time. And there it is. So there's a new transaction we just sent. So it's that quick, everything is instantaneous. This is what I love about, working with blockchain here. And there you can see the mainnet always has the algo price, which I love. And then you can see here, I'm going to go ahead and put in that same, we'll just search on that transaction. And there it is. It's got the exact timestamp that we did it. The block was created in, and the sender, receiver, and the note field, everything is displayed there as well. So some great tools right off the get-go to become familiar with. On atomic transfers, this is where you have a person A is going to be sending over like 50 algos to person B. And in return, person B must send a concert ticket. Or if neither of these happen, none of it will happen. Both of these have to happen for the entire transaction to be legit. All must succeed or it'll fail. And then this again is native, easy and secure, up to 16 transaction, guarantees a goods exchange. But here is the most, I should make this bullet point huge. You can combine this with other Algorand technology. And this is the secret sauce. A lot of times it'll hold a solution together, and you'll see this on an illustration I got coming up. But the idea here is maybe you've got a smart contract in the mix too that also has to sign off on this as part of the logic flow. So, or you've got assets, right, that you might be trading instead of algos. So again, those could all be included in atomic transfers. So very, very useful thing. Some examples, real world examples, you can see listed here. Enabling multilateral trades, circular trades, group payments are all very possible, distributed payments as well. Get to smart contracts, TEAL, transaction, execution, approval, language. There's also a Python-enabled compiler. So TEAL is like assembly language. Again, learning from past experiences and mistakes from other blockchains. There's no VMs, right, that are running on the blockchain. This is all assembler code, which doesn't get much faster and leaner and meaner. And but if you are really loving Python, for example, we had a lot of folks reply to that. I would say Python enabled compiler would be something to check into, or PyTeal. So you write it in PyTeal and it'll generate the teal for you. Two types of smart contracts. We got stateless and stateful. So stateless is used to sign a transaction. If the contract returns true, it'll sign it. And stateful also has global and local storage available. So local would be at the account level. Combinable as well with other Algorand technologies, atomic transfers, Algorand assets. You've got combined stateless and stateful contracts. And Algorand stateless smart contracts does replace the signing of transactions or supplement it. The logic account is any transaction sent from this account will be verified by predefined logic. Examples are escrow style accounts, split payments, hash time lock contracts, as well as logic signatures, as well with recurring payments. And you'll see this as well. The stateful smart contract lifecycle would be to create an application, And this would actually live now in the blockchain. You would have an app ID that gets associated with that. You'd have global storage that's available, local storage that's available at the on the account level. There's a no-op, which is actually the same as calling the app. You can update the application too. So if after you've submitted it, maybe you want to make some enhancements to it, you can update that application. And then also you can have the ability to delete the application and close out. The TO logic must be true in that scenario. Clear state will always clear it. So those are kind of the major functions you have dealing with smart contracts. Algorand accounts, 3 of them, 3 types: standard, multi-sig, and logic. So the multi-sig is basically like analogous to when you go to a bank and you cash a check, where you have to have 2 signatures sign the check. So you have multiple people that need to sign off on it. You define what that threshold is. Let's say you got a group of 10 in the multi-sig account, and maybe you say at least 3 of you got to sign off on it. So the threshold would be 3. Logic account, like I said, if it returns true, it signs it, and then you have the standard account that gets has the spending key on it. The reason I brought those up because this leads into the Rekeying fee feature that we have on the blockchain. No other blockchain offers this. It's a way to spend, change your private spending keys very easily. And the way it works is basically you've got a public key versus private key. The public key is the one you want everybody to know, because that's how you're going to get your money, right, or your assets. They're going to send it to your public key. The private key, on the other hand, you don't want anyone to know except for yourself, and that's where you keep it either on a Nano X Bluetooth ledger, or you have a piece of paper, you write your key down, stick it in your safe. You do not want to have this on your machine. You don't want to be sending it in emails. These are some of the precautions you would take in this day and age on private keys. But what happens if you want to, say, start with a single account, and you want to maybe get a board of directors now, and you want to switch this to be a multi-signature account and sign with that threshold of a certain number of folks? Or maybe you progress and you build a smart contract that does everything, and you want that to be the one that signs it. Well, you had to create a new pair before. Now with Rekeying, you simply key the authorized address of the new signer. And you can see that this is actually a new field in the transaction record where you have an authorized address going to a different account to do the spending. So very, very creative and very useful. We have the wallet, Algorand Wallet. You can download this from the App Store. A lot of developer features on it, including testnet, mainnet settings. So another way to verify your transactions when you're developing. We've got the Nano X ledger support, and you can rekey to the ledger, as well as asset support is provided. So you can add assets to your wallet. Again, the asset ID would appear in the list. Okay. Smart contract value, finance industry, right? Real big. Trade finance, clearing and settlement, financial data recording, digital identity, as well as escrow payments, credit lending, and stable coins. So this kind of gives you a feel for the DeFi space. And then Indexer facilitates querying the database. So before Indexer came along, we had to search the blockchain, and that was excruciatingly painful and very, very slow. And this really helps rectify that problem. And what we've done is you have an algo daemon, which you would normally use in your code to access the Algorand blockchain natively. So you can do things like query, give me an account, or give me transactions, or give me assets for this account, that sort of thing. But if you wanted to start querying that, like maybe you're building a leaderboard for a game, and you want to have the ability to query, who holds the most assets, right, in this game, who has the most tokens, then they would be, on that leaderboard. So things like that started to get pretty cumbersome to do. And what we've done is basically offloaded that process to a PostgreSQL database. And it's very easy. It's like a regular database now. You just query that database, and very, very, very robust, and it's available through all the SDKs as well. So how do you do this? Well, you can build your own. It'll take a while to build that, several days, and you need lots of space. And then also there are other options. You can use a service like PureStake and RAN Labs. And also now the sandbox does provide a by default a private network, and that includes an indexer because it's going to be building the indexer as the blocks are created. The private network starts at your Genesis block and then builds from there. So that's a very good way to do testing and get set up for running, is through the use of the sandbox. Take a look at some of the architecture. Some of your apps and solutions will start, looking like this. Let's cover through the voting example, where you'd have a voting commission account with a spending token, a voting token. Now these are going to be atomically grouped. So this is where the atomic transfers fit in. All of this needs to happen or none of it will work. And then you vote for candidate A, and then you have a voting smart contract that will increment the candidate A vote total, and that would be a global state. So that would be a stateful smart contract, writing global state out to the vote total to the blockchain. So very simple and very effective, and something that you could piece together or imagine all the pieces pretty easily. Now, how about crowdfunding? Another popular example today, a use case for a blockchain. Because think about the scenario, right? You have several people that are going to be willing to donate funds to this, but only if the threshold is reached, the amount of funds are raised for this project to take off. Otherwise, if it's not by a certain date, then everybody's going to get their money back. So again, atomically grouped, you have maybe a stateless smart contract that does some of that logic up front, and then you have a payment from escrow to user one. Then user one claims the escrow funds, and then now you got a stateful smart contract that does the rest of this on the crowdfunding application. So there you see you have both the stateless smart contract, which returns true or false. Have we hit our limit, right? Have we reached the threshold of funds being raised? And then smartful contract might be looking at different state on the individual accounts, saying, okay, here you go. You've got this funds. They're going to be distributed to you. And let's go ahead and, put that total out there. So there you have an example there. All right, Ryan, we got any questions at this point before I dive into DevTools, last part of the session?
No, actually, we've had some questions specifically about this. So I think that this is where a lot of the questions are focused. So keep right on going, Russ. Thanks very much.
Great, we got it. Thank you very much. So we got a great developer portal, developer.algorand.org. You've got lots of great docs, including, how to get started. In fact, that I probably should point that out. Right there it is, upper left corner, start building. And when you click on that, then you see you've got the workspace set up, connect to a node, your first transaction, and building applications or smart contracts. So, 4 steps right there. So very, very good, laid out nicely, and gives you lots of good code examples in there. In the first transaction, you'll see, for example, JavaScript code, Python, tabs, Java, Go, how to do it in Go, which is our command line tool, and another tool for doing signing here, Algo Key. So those are listed where applicable, and you can see all the code right down here. And then typically at the bottom will be a URL for the completed code. Always go to V2, and then you can see the different languages that are supported, and there's your first transaction code in Python. So a great resource there. And then we have the different networks. You've got the testnet and mainnet, which are already in parallel. You get to betanet, which is new protocol. Releases would be going in there, and private networks that can run any flavor of those. A typical example of a private network or a personal network, I like to refer to it as, is basically you have the ability to kind of like take a snapshot of betanet. And I like to use the betanet as an example because that's always changing in the state of flux in terms of the protocol usage. So you get some stability on your testing. You could test it with one kind of a build, right, for betanet, and then see if it works there and get your testing done, and then go ahead and continue on with more testing. So those are the networks. In terms of the nodes, basically you can get your own copy of the ledger with this, right? So you create and run your own on Mac, Ubuntu, other Linux distros as well as Windows. It used to take several hours to sync, but now there's fast catch up. So matter of minutes now, hours to minutes, which is great. You don't have to create a node to do programming against the Algorand blockchain. There are services that are available that have fully indexed and archived servers by PureStake and Rand Labs. Also, you can access SDK code on the platforms that do not have nodes, right? And then the last step on that slide was the sandbox. It's Docker. It's a Docker instance, not for production. Snapshot starting, no current node, no sync time. So real simple. You clone the repo, install Docker, and now you got Sandbox running, and it can run on Mac and in Windows as well. So there it is. How do you get going? Well, you just type in .sandbox up, and then if you want to go to a certain environment, add that as a parameter like testnet. By default, it'll go to a private network where you have indexer available. Then you see in the README file here on the sandbox are the URLs for the address and the tokens that you would use for this. And you would put this in your code. And I'll show you that in a second. So we got lots of tools. You got IDEs on the right. Algodia is a great one. You'll want to, I'm going to give you a demo on that shortly. You want to use that. You've got Reach, you got PyTeal in the middle here. Reach is a great environment to build cross-platform solutions for both Algorand and Ethereum. And you can do it in a higher level language like JavaScript, and they have a few others now as well. SDKs are on the right. So everything you see here in the red square is by Algorand. Everything else here is by community. So we're really getting a very thriving community on the code tools. So let's take a look at creating accounts and also your first transaction. And so what I'm going to do here is bring up there it is. Java will be a first language that we go ahead and do it. And I've got this create accounts Java. And I'm just going to go ahead and run this. And then you can see me hit my breakpoint here. And I'm starting to print off these addresses down below. So you have both the addresses and then you have the passphrases that this generates for you. And then you can restore these addresses from the passphrase with some SDK calls going forward in testing your code. So that's the first step. Now I copied off that address. So let me go ahead and bring up the dispenser. And the dispenser I've got over here. And all you do is paste in that address and dispense. And now if you were to look at this account in one of the browsers, you see that you would have some algos in it. You need to have algos in it to do what? To do transactions, because there's a fee that's associated with that. So going back over to the Java example, let's take a look at doing your first transaction. All right, so now what we're going to do is first get the transaction params. We got a receiver. We're going to do a send of assets. We're going to put a note field is free form. You can put anything you want. Here we got a string. You could put a structure in there. Here we are taking that passphrase that we had before, and we're passing in it as a parameter on the account. And this will get you your actual account, which has both the address and then the signing key that you would need to sign. I want to emphasize this technique is good for demos and tutorials, not for production. You want to take your key, store it into like AlgoSigner, use one of the APIs there to pass it out. There's another tool called MyAlgo that we did on our dev office hours that would be along the same lines, except it's not a plugin. It's actually something you can communicate with in your web browser. So, and if you're writing a app like an iOS or Android app, you might want to look at the secure storage app. Just secure storage class. That's where you want to be storing private keys if you're going to be storing them in the app. So just kind of give you the laydown on that. Now I'm going to continue. I'm going to get the response. So this response is going to have various fields in it, and the parameters that you can see there are going to be like the fee, the Genesis ID, the last round, the minimum fee. And then we're actually going to do the transaction. So now we got these parameters for the transaction. You got the sender address, you got the note, you got the amount we're sending, you got the receiver, you got the suggested params, and we're going to build it. And I'm just going to hit run here to continue this. And then the next step is to sign it. So now we've got the transaction, and now we're going to sign it by who's in the transaction. We put in the sender in the transaction. So that's the one that's going to be doing the signing here. And then the last step is to broadcast it to the blockchain. And that's what this raw transaction does. At this juncture, if the account has insufficient funds, it'll fail right there on that step. And then you have a wait for confirmation. This will go ahead and take that transaction ID. And, you know, again, it takes about 5 seconds to run. And once that's done, then you would see it print off the information down below in the terminal output. Okay, so that was a success. And then what we'll do here is take a look at the same thing, but in Algorand, and just show you how much easier this IDE is. So this is Algorand. You're definitely going to want to download this first after you get all the SDKs installed and things of that nature. And so what I'm going to do is just right mouse click here. You see a little teal program there in the back. We'll get to that in a second. And you could create a new account. So let's create a new account. Encore. And then go ahead, hit OK. And then you can right mouse click again. You can see Algorand Accounts. Let's go ahead and list the accounts. Yeah, I'm not quite sure if I populated that yet. So fetch the balance on each of these. You can see I got 0 there. So I do the same thing. I copy that, address that go out to a dispenser and dispense some funds to it. What I'm going to do is you can also just delete it and remove it. And you got really nice account management. So very, very easy, no code needed, right, for the non-developers out there. But even for the developers, this is a great IDE. So you saw all the code I had to do for the transaction. I'm actually going to do a little bit more complicated transaction. And I'm actually going to do a smart contract here. We're going to do a delegated contract. So I'm going to go ahead and do a new I'm going to go ahead and do a stateless contract. We're going to generate a logic sig, and I'm going to do what's called a delegated signature. So a contract account will just have to return true, and it'll go ahead and sign it. Delegated signature has to return true, plus it's got to be signed by, let's say we're going to send from Alice to Bob here. And so now I'm going to generate this LSIG, and you can see it pop up on top. And what we're going to do is execute this teal. So this is transaction execution approval language, and it's a very simple program. You've got a receiver, and the receiver's got to be Bob's address. And the transaction amount, it's got to be less than or equal to 1 algo. And that's what we're going to test for in our smart contract. So I'm going to go here. I'm going to send a transaction. First transaction I'm going to do is I'm going to send the receiver. I'm going to make it Russ demo rather than Bob. And what you should see is a failure. I'm going to go ahead and send in 1 algo, hit that, and you can see it failed, right? And you can see down there the error message, and it failed because it didn't meet the criteria in the contract. So now let's do another one here that works. I'm going to go ahead and go to Bob, which is this WCM account, which you see in the contract. And then I'm going to go and do 1 algo again. And now it's going to successfully work and send that transaction. All right, so that is kind of the lowdown on those. And I give you the demo on Algorand and smart contracts. So now let's take a look at multi-sig. And to demonstrate that, I'm going to go over to Python. And I'm going to run this file. I've already got the breakpoint set. It's the same process no matter what language you use, right? You're going to go ahead and get your suggested params. You're going to do the transaction. But now this part's a little bit different. Now we're going to do a multi-sig transaction where we got 2 sign-offs on it, right? And we've got a threshold, a multi-signature account that we've got set up here. And we take a look, here's the address and the token that we had talked about to instantiate the client SDK, which you can see right there. And then we've got the multi-sig gets created right here. That's what I was trying to find. So you've got the version number, you got the threshold. So 2 out of this group have to sign it, and the group only has 2. It's got 2 accounts in it. So if you wanted to have 10 accounts, you just list them all one after another there in that multi-sig account. So that's the threshold. So that gets set, and then now I'm just going to go ahead and continue on here, and now I'm going to send the raw transaction out, and then what we'll see is the wait for confirmation method being called, and then you'll see this come out in the display down below, the information for that particular account. All right, so that's pretty cool stuff. And then the next thing is atomic transactions. So, let's go ahead and take a look at Go on this. So let's change this to Go, and we'll go ahead and take a look at this code and doing atomic transactions. And then you have the mnemonics, right? We're going to restore. We talked about that, but here is the actual payment on an atomic transaction. So there's going to be 2 of them actually. So the first one is going to go from account 1 to account 3. That's going to be 1 algo. These are in micro algos. And then the second one is going to go from account 2 to account 1. And both of these transactions need to occur, need to be successful. And so if I go ahead and continue running this, now I'm going to take these transactions. We're going to create a group ID that associates them all as a like, object. And then I'm going to go ahead and sign it with both of the keys. So I'm going to do a signed transaction up here for the first transaction. Then I'm going to do another signed transaction here. And then we're going to take both of those, combine those into the group, and then we got to send the raw transaction to the group. And that's really the piece that's needed there to get that done. And you can see everything was successful down below. All right. Let's just talk about smart contracts, stateful smart contracts now. So you could use PyTeal. That's optional, right, to generate teal. And the command to do that is compile teal. We'll compile it from Python into teal. Then once you have the teal, you need to compile that into a binary format that's going to byte array that's going to get passed into a call, like creating the application. So here you would have the compiled, they call it approval program, and you can see that as a parameter that gets added into the create text. Then we got debugging on smart contracts. So there's 3 things that you want to debug typically: the accounts, the signed transactions, and the approval program source. These all go what's into a dry run request. And then you can see the debug teal debugger with generating the request code with everything in it. And then you can use the Chrome inspect to go ahead and inspect that. And what I have here is a example set up, ready to go here on this. Nope. Where was it? I think I missed it. Hold on one second. I'll get this for you. Okay, and right here is the dry run request. Let's see if this works. No, I got to do directory thing here, SDK examples. All right, now we should be cooking with gas. And there it is. So I'm going to go now over to Chrome and take a look at this with Inspect. And there we have it. So I'm going to go ahead and inspect. So this is a contract, a very, very simple teal program that we have, but you can step through it and you could see it, information on the right in terms of the global and the locals, as well as the scratch and your stack, right? This is going to return true or false at the end. And you want that to return true. And then I can see a counter was just added right into the mix. And then we're going to take that and go ahead and we did a app global get of that particular counter. And now we're going to go ahead and put that out to the stack and then return that value back that we get in the stack there. So that is an example of the debugger. And I think we're in pretty good shape here. There is one more thing to show you, and that is the indexer. If you go out to this link in the deck here, you'll see some run in Postman prompts, and you can actually start testing your API and API testing tools like Postman. And for example, here is the REST endpoints, right, that I talked about that would be in there. And if I go ahead and bring up an example from code, I'm trying to do this, they say, from JavaScript, this will be our final language of the day. I have a bunch of indexer queries here. For example, get info on a block. This is going to, whoop, that's in Go. Let me go to the right language. JavaScript. All right, great. So you can see here, this is actually using the PureStake indexer, for example, right? Where you have the information there to create your API. And then what I'm going to do is just do a lookup by account ID. So if I go ahead and fire this up, you'll see that information come back down below. And there it is, the client. We're going to look up this account that is being fed in there. And there you have the information down below. Now, if I take a look at that account in Postman, which you might be doing if you're using a private network, because there's no explorers available in private network, only for testnet, mainnet, and betanet. You can actually just run that same query over here for that same address. And you can see here, this is where all the assets are. So this is all the holdings that you're seeing up in this top part. Then you can also see the created apps that are in there, as well as their global state. Then you can also see created assets. So this is all the information that gets written to the account when you get the created assets. And then similarly, there is created, there's apps that have opted in, and you would see that information there if this account had some of those. So that's the lay of the land. And let me just wrap up here with some summary slides and resources, and then we're going to go ahead and end this session here today. Great developer newsletter. Make sure you sign up on the developer site. It's in the footer there. There's a newsletter button. Ryan publishes that every week. You'll love it. Community projects. We saw a few here I talked about today, like with Reach and Algorand. They're all on this page on the community site. And then also Reach is a great product to go ahead and build simultaneously to multiple networks. And basically what I have here is an example of that. It is a using Reach, and the way it actually works, I could run this game. It's a rock, paper, scissors game where you enter the name and you know the outcome, and you get the outcome of whether winning or not, and pasting the contract name. But basically, just let me describe it. You have the Reach files, which define all your structures, and then you have, this is like a JavaScript file that defines some of the methods and functions that you would need, plus all the prompting. But here's the magic, right, is in this Docker Compose YML. If you want to deploy to Algorand, and you just go down to this reach statement here, this with Algo in it, and you put that as the default app. Then when you go to build this, it's going to build it for Algorand. If you wanted to do this for Ethereum, you'd cut this here and then paste this up on the Ethereum line, which you see right there. You just paste it right there and then rebuild it. So that's how easy it is to start doing that with Reach. And then a great MetaMask like Chrome Wallet, Algo Signer, we showed you the demo on that. There's also an SDK on that. And My Algo Connect, another great solution for working with private keys in your applications. Algodia, tremendous. You'll get a lot done faster, quicker with Algodia. Also, we got some community projects as well as some grant programs and ambassador programs, and these are all on the deck for you to take a look at, as well as links to the code samples and developer office hours. We just did one on Teal 3 this morning, so the recording should be available soon. And then NFT design considerations. I believe Ryan's going to be doing that in a couple weeks. So again, sign up for these and see all the videos from the prior ones at this link too. Algorand.com developers, great resource. This is the best. When you start working with Algorand and you got questions, pop the question in Discord. Use this link on top. Ryan, you may want to paste that one into the chat window. Have everybody join right now. And then also you've got the other links for the forums are useful too. That's the link to today's PowerPoint, that 3RTW4G. I want to paste that in there too, Ryan, into that into the chat window. And then these are other resources that are in the deck on, debugging with VS Code, Algorand Studio, didn't even talk about that, another great tool. You've got the Algorand Playground, another great tool. Algorand Builder. The community has been very, very strong. So in summary, what I'm going to talk about here is basically we covered a lot of things here today. We covered blockchain use cases. I'll give you some ideas there on different scenarios you can put together for a blockchain, and really it applies to many verticals in the industry, not just DeFi. DeFi is definitely the biggest. And then we covered a few blockchain basics with different record types that are in the ledger. And then layer one features, we kind of did a high level overview of that with ASA and smart contracts, both the stateful and stateless features, and lots of great developer tools. And we went from Algodia to actually showing you code in 4 different languages. There's fully featured in C# and some of the other SDKs that are out there. We also have some new SDKs on Unity and Swift and PHP. And those are all available as well through that community page. And I will end here with the link to the PowerPoint, and I'm going to see if we got any questions that need addressing. And say hi to everybody. Hi.
I don't see any additional questions there, so I think we turn it back over to Anthony then.
Yeah.
All right, Anthony, you got it, man. Thanks.
Ryan's been a machine on chat. Every time a question come up, it was like,
he's amazing, isn't he?
Well, what a fantastic event. Well, thank you everyone for joining us, and most importantly, thank you to Russ and Ryan for such in-depth kind of look into Algorand and getting started. I certainly learned a lot, and I think I've heard this talk about 2 or 3 times by now.
Hey, there you go.
Well, thank you everyone for joining. This concept of this YouTube and the Medium will go up later tomorrow. Russ will send his slides over as well. I think the slides are actually already available. I saw Ryan put those on chat. Yep. The next event is in 2 weeks, or 2 weeks yesterday, and that's, I believe, on Algorand standard assets. We'll go in depth on those. But for now, unless there's any more questions, Ryan, Russ, thank you so much for your time this evening, or this morning for you guys, and early afternoon for you guys. See you all in a few weeks.
Yeah, I'll be delivering that session next time around on ASA.
Sweet. Okay, guys, Thank you very much, and see you all soon.